The year is 1978. Gas lines stretch for blocks. Americans are desperate for fuel efficiency. General Motors unveils what they claim is the solution: the Oldsmobile 350 diesel V8. It promised 30% better fuel economy than gasoline engines, and it was going into everything from Cadillacs to Chevrolets. But within just a few years, this engine would become one of the most catastrophic failures in automotive history. It didn't just fail, it destroyed itself, stranded hundreds of thousands of owners, sparked lawsuits, and killed consumer trust in American diesel passenger cars for the next 30 years. This is the story of how GM's Oldsmobile 350 diesel became America's biggest engine disaster. To understand this disaster, we need to go back to the mid-1970s. The 1973 Arab oil embargo had sent shockwaves through America. Gas prices quadrupled overnight. Americans waited in lines for hours just to fill their tanks. The muscle car era died instantly. Those big block V8s that guzzled premium fuel, suddenly they weren't so appealing anymore. Then came CAFE standards. Corporate average fuel economy regulations were forcing automakers to achieve fleet averages that seemed impossible with the technology of the day. By the mid-1980s, manufacturers would need to hit 27.5 miles per gallon across their entire lineup. That was a massive problem for companies like GM that built their reputation on full-size cars with V8 engines. European manufacturers had a solution: diesel engines. Mercedes-Benz had been building diesel passenger cars since the 1930s. By the 1970s, their diesel engines were refined, reliable, and delivering fuel economy numbers that gasoline engines simply couldn't match. Peugeot, Volkswagen, and others were seeing success with diesels too. GM looked at this and saw opportunity. Diesel fuel was cheaper than gasoline. Diesel engines were inherently more efficient due to their higher compression ratios and thermodynamic advantages. And here's the key: diesel fuel economy could help GM meet those looming CAFE standards without having to completely redesign their fleet or abandon V8 engines altogether. The plan made sense on paper. Americans wanted their comfortable, spacious cars. They just couldn't afford to fuel them anymore. A diesel V8 that could deliver 25 to 30 miles per gallon in a full-size sedan, that sounded like the perfect answer. But here's where everything went wrong. Instead of designing a diesel engine from the ground up like Mercedes-Benz had done, GM made a catastrophic decision. They would convert their existing Oldsmobile 350 cubic inch gasoline V8 into a diesel. This wasn't just cutting corners, this was ignoring fundamental engineering principles. See, diesel engines operate completely differently than gasoline engines. A gasoline engine uses spark plugs to ignite a fuel-air mixture. Compression ratios are relatively low, typically around 8:1 to 10:1 in engines of that era. A diesel engine has no spark plugs. It compresses air to such extreme pressures that when fuel is injected, the heat from compression alone ignites it. Diesel compression ratios are typically 17:1 to 22:1. That difference matters enormously. Those higher compression ratios create exponentially higher cylinder pressures. A diesel engine experiences roughly 50% more peak cylinder pressure than a comparable gasoline engine. That means every component needs to be significantly stronger. The block needs to be thicker and more rigid, the heads need to be beefier, the head bolts need to be larger and more numerous, the crankshaft needs to be forged, not cast, the main bearing caps need more support. GM's Oldsmobile 350 gasoline V8 was designed for none of this. It was a perfectly adequate gasoline engine that had been around since 1968, but it was never, ever designed to handle diesel compression pressures and loads. To GM's credit, they didn't just bolt a diesel fuel system onto a gasoline engine and call it a day. They did make some modifications. They increased the compression ratio from around 8.5 to 1 to 22.5 to 1. They strengthened the block somewhat by using more nickel in the casting. They used different pistons, a different camshaft, and added a diesel fuel injection system from GM's collaboration with Standardine. But here's what they didn't change: the basic block architecture, the number and size of head bolts, the head gasket design, and most critically, the crankshaft remained a nodular iron casting instead of a forged steel piece. The main bearing caps used the same basic design as the gasoline engine. Engineers within GM knew this was problematic. There are reports that some Oldsmobile engineers raised concerns about the engine's durability. But management was under intense pressure. Development time was compressed. Money was tight because GM was spending billions redesigning their entire fleet to be smaller and more fuel efficient. The diesel project needed to happen fast and cheap. In 1978, the Oldsmobile 350 diesel debuted. It made 120 horsepower and 220 pound-feet of torque. Not impressive numbers, but adequate for the era. And it delivered on the fuel economy promise. Cars equipped with the diesel were achieving 25 to 30 miles per gallon, sometimes more. That was remarkable for a full-size American car with a V8. GM was so confident in this engine that they installed it across their entire range. You could get it in an Oldsmobile Cutlass, a Buick Regal, a Pontiac Grand Prix, a Chevrolet Caprice, and even in Cadillacs. In 1980, the diesel was actually the standard engine in the Cadillac Seville. Yes, Cadillac's luxury sedan came standard with this engine. Initial sales were strong. In the first few years, GM sold hundreds of thousands of diesel-powered cars. Americans were attracted by those fuel economy numbers and the lower price of diesel fuel. And then the engines started failing. Not occasionally, not rarely, en masse. The problems with the Oldsmobile 350 diesel weren't subtle teething issues. These were catastrophic, engine-destroying failures that often left owners stranded. The most common failure was head gasket failure. Those higher diesel compression pressures were simply too much for the gasoline engine-based head bolt pattern and gasket design. The head gaskets would blow, often before the car hit 30,000 miles. When a head gasket fails on a diesel, it's not just a minor coolant leak. Coolant gets into the cylinders. The engine overheats. Sometimes it would hydrolock, which means liquid coolant filled the cylinder, and when the piston tried to compress it, something had to give. Usually that something was a connecting rod. But it got worse. The cylinder heads themselves would crack. The combination of high compression pressures, thermal stress, and inadequate head bolt clamping force would cause cracks to form between the valves or around the pre-combustion chambers. Once a head cracked, the engine was essentially dead. The crankshafts broke. Remember, GM used a cast nodular iron crankshaft instead of a forged steel unit. Diesel engines create different loading patterns on the crankshaft due to their higher compression pressures and the way diesel combustion occurs. The cast crankshafts simply couldn't handle it. They would develop cracks and eventually snap, usually at high mileage if the engine survived that long, but sometimes much sooner. The main bearing caps would walk or shift because the block wasn't rigid enough to control the forces generated by diesel combustion. This caused bearing failures and oil pressure loss. But perhaps the most insidious problem was the fuel injection system. GM used a Standardine mechanical fuel injection pump, which itself was a decent piece of equipment. But diesel fuel has lubricating properties, and the injection system depends on that lubrication. If water contaminated the fuel system, which happened more easily than it should have due to various design issues, the injection pump could seize, and when it seized, it could take out the entire fuel system. Making matters worse, many owners didn't understand diesel maintenance requirements. Diesel engines require different oil with higher detergent levels. They need more frequent fuel filter changes. The fuel system is less tolerant of contamination than a gasoline carburetor. Many owners and even some mechanics treated these engines like gasoline engines, which accelerated their demise. GM initially tried to downplay the problems. They issued technical service bulletins suggesting repairs and modifications. They extended warranties on some components, but the failures kept mounting. By the early 1980s, the Oldsmobile 350 diesel had earned a reputation as one of the most unreliable engines ever installed in an American car. Owners were furious. Many had bought these cars specifically for fuel economy and reliability. Instead, they got massive repair bills and cars that spent more time at the dealer than on the road. The backlash was swift and severe. Class action lawsuits were filed against GM. Owners claimed the company knowingly sold them defective engines. Internal documents would later surface suggesting that GM was aware of durability concerns before launch, but proceeded anyway. GM eventually settled multiple lawsuits for millions of dollars. They extended warranties and offered compensation to some owners. But the damage was done. The Oldsmobile 350 diesel lived on through 1985 in some applications, though GM did make improvements over the years. They eventually addressed some of the head gasket issues with better gaskets and revised head bolt torque specifications. They improved the block casting. But it was too little too late. The engine's reputation was destroyed. More importantly, the entire concept of diesel-powered American passenger cars was poisoned. For decades afterward, American consumers wanted nothing to do with diesel cars. Even when Volkswagen, Mercedes-Benz, and later other European manufacturers brought excellent modern diesel engines to the U.S. market, many Americans remembered the Oldsmobile diesel disaster and stayed away. This is particularly tragic because diesel technology improved enormously in the following decades. Modern diesel engines with electronic fuel injection, turbocharging, and emissions controls can be both powerful and efficient. But GM's botched execution in the late 1970s created a stigma that lasted well into the 21st century. Here's what makes this story particularly frustrating. GM was actually onto something. They correctly identified that diesel technology could help solve the fuel economy crisis while maintaining the performance characteristics Americans wanted. Look at what happened in Europe. Throughout the 1980s and beyond, diesel passenger cars became increasingly popular. By the 2000s, diesels represented more than half of all new car sales in many European countries. These weren't slow, rattling, smoke-belching engines. They were refined, powerful, efficient, and reliable. Mercedes, BMW, Volkswagen, Audi, and others all offered excellent diesel options. If GM had invested in properly engineering a diesel V8 from the ground up, or if they had partnered with a diesel engine manufacturer who knew what they were doing, history could have been completely different. They could have established themselves as diesel pioneers in the American market. Instead, they became a cautionary tale. The saddest part, GM did eventually learn the lesson. In 1982, they introduced a new diesel V8, a 6.2-liter engine that was actually designed as a diesel from the beginning. This engine was much more successful and was used in GM trucks throughout the 1980s and into the 1990s. It wasn't perfect, but it was reliable enough that many of these engines are still running today. But by then, the damage to diesel's reputation in passenger cars was done. Americans had decided that diesel was for trucks and tractors, not for their family sedans. The Oldsmobile 350 diesel stands as one of the most spectacular engineering failures in automotive history. It was a product of rushed development, cost-cutting, and management decisions overriding engineering concerns. It was a case study in what not to do when developing new technology. The consequences extended far beyond GM's bottom line. Hundreds of thousands of customers lost trust in General Motors. The entire American automotive industry's reputation took a hit, and diesel technology in American passenger cars was set back by decades. Today, more than 40 years later, the Oldsmobile 350 diesel is remembered primarily as a disaster. You occasionally still see survivors, usually in the hands of diesel enthusiasts who have extensively modified them or rebuilt them with proper diesel-grade components. But most ended up in junkyards long ago. The lesson here isn't that diesel engines are bad. The lesson is that engineering fundamentals cannot be ignored. You cannot simply convert one type of engine into another and expect it to work. Sometimes the right solution requires starting from scratch, even if it costs more and takes longer. GM had the right idea with the wrong foundation, and that combination became America's biggest engine disaster.